The interlobular artery gives off tiny afferent arterioles, which run into the lobule to supply the renal corpuscles. The afferent arteriole enters the renal corpuscle, breaks up into a tuft of capillaries called the glomerulus, and then collects back into an efferent arteriole instead of a vein. However, really, it would be impossible to tell whether this is an afferent or an efferent arteriole. But I think you get the message. But I'm sure this little aggregation of nuclei next to this blood vessel may be a macula densa. So perhaps this is an afferent arteriole. But we refer to this region of the glomerulus as a vascular pole. The efferent arterioles run for only a short distance before breaking up into a second bed of peritubular capillaries, which nourish the proximal and distal tubules and pick up fluid. Even when these capillaries are collapsed, you can see abundant red blood cells inside their lumen. Before I leave this image, look here, where the parietal layer of Bowman's capsule becomes contiguous with the proximal convoluted tubule. This area is referred to as the urinary pole. And just make sure you're happy distinguishing the proximal convoluted tubules from distal convoluted tubules. Efferent arterioles from those nephrons situated near the boundary between the cortex and the medulla take a different course. They break up into long, thin capillary vessels which descend straight down to the medulla and then loop back up to the boundary. These capillaries are called the Vasa Recta. They provide nourishment to and reabsorb water from the medulla.